All right, so trig functions of general angles. So our main idea, our main concept, theta is going to be an angle in standard position, and we're going to let P of x comma y be the point on its terminal side. So standard position, remember means on a coordinate plane. The vertex is at the origin. The initial side is on the positive x-axis. And then what's going to happen is we have some point P, x comma y, and it doesn't matter where P is. And our terminal side is going to go through this point P. So this would be the angle we're looking at. So we're going to use the Pythagorean theorem to find R. So what's going to happen is we're going to take P and we're going to make a line from P straight down to the x-axis to form a right triangle. Now once we do this distance along our x-axis here, so this distance here on our x-axis is our x value of point P, and this distance here on our y value of point P. And we're going to let the hypotenuse be R. And we would find R, we could use the Pythagorean theorem. So we're going to find the 6 trig functions of theta. So we're going to have to remember from geometry or from Monday our SOHCAHTOA. So what this is saying is that sine of theta is going to be the opposite. So on this triangle, the opposite of theta is y over the hypotenuse, which is the one across from the 90-degree angle, which is r. Cosine of theta is the adjacent to theta. So adjacent, here's theta. Adjacent means next to, so the one next to theta is x, divided by our hypotenuse, again, which is r. So the tangent of theta, sorry for this correction, SOHCAHTOA. So tangent is the opposite over adjacent, so the opposite of theta is y over the adjacent, which is x. Now it says 6 trig functions. We do have, they're called reciprocal trig functions. We have cosecant of theta, which is the reciprocal of sine. So we're going to take our sine and flip it. So it's going to be r over y. We have secant of theta, which is the reciprocal of cosine. So it's r over x. And cotangent of theta is the reciprocal of tangent. So this would be x over y. And basically all of these here, it's going to be asking for all of these 6. This is going to be your answer, writing out what these trig ratios are. All right, so the terminal side of theta in standard position goes to the point 6, 8. So again, these graphs don't have to be super drawn to scale. We're really, again, just looking for the correct quadrant. So 6, 8 is in quadrant 1. Kind of a wonky looking. Better. So I draw my angle theta, and then I'm going to make a right triangle, which means the base of my triangle is the x and the height is the y of 8. Now to find our r, we're going to use Pythagorean's theorem. So 6 squared plus 8 squared equals r squared. So this would be 36 plus 64 is 100. So 100 equals r squared, which means 10 equals r. So once you get your x, y, and r, we're going to write our answers. So sine is the y over r. So this would be 8 over 10, which would reduce down to 4 over 5. Cosine of theta is our x over our r. So our x is 6. So this would be 6 over 10, which can reduce to 3/5. And tangent of theta is y over x. So this is 8 over 6, which is 4/3. Cosecant of theta is the reciprocal of sine, or it's r over x. So if we just flip what I have, that's 5 over 4. Secant of theta, r over x, which flipped of cosine would be 5 over 3. And cotangent of theta is x over y, so 3 over 4. So if you'd like to pause this video and try number 2 on your own, you can. I will also be working it out as well. So feel free to pause it or just keep watching, and here we go. So we're going through the point -3, -4. So -3, -4. And again, it doesn't have to be super accurate. We're just looking for it in the correct quadrant. So we're going to make a right triangle, always with the x-axis. Here's our angle. So our x base is -3. The height of our triangle is -4. So to figure out our hypotenuse, we can use our Pythagorean theorem. -3 squared plus -4 squared equals r squared. So 25 equals r squared. So 5 equals r. R is always going to be a positive number because it's the distance. So sine of theta, this is our y over our r. So this is -4/5. Cosine of theta is our x over our r. So this is -3 over 5. And tangent of theta is our y over our x. So -4 divided by -3, the negatives will cancel out. So I'll just end up with 4/3. And then our other three are reciprocals. So this will be -5/4 because it's r over y. Secant of theta is r over x. So this would be -5/3. And cotangent of theta is x over y. So -3 over -4, which will make a positive, change to green somehow, 3/4. All right, and then example 3, -3, 2. So when I sketch this out, -6, 2. So -6, 2 would be in quadrant 2. So it'd be over here. Make our right triangle, and here's our angle. -6, 2, so -6 is x. 2 is our y. To find our r, Pythagorean theorem, so -6 squared plus 2 squared equals r squared. So 36 plus 4, this gives us 40 equals r squared. So the square root of 40 equals r. So we don't want to write the decimal of this. We want to leave it as the exact, but we can simplify this square root of 40. If we remember how to do this, square root of 40, you can either factor tree or look at perfect squares. I like perfect squares. This is the square root of 4 times the square root of 10, which is 2 square roots of 10. So when I look at sine of theta is y over r. So y is 2 over r, which is 2 square roots of 10. So now when we simplify this, these 2's can cancel out, because one's on the top and one's on the bottom. But remember, we're not allowed to divide by a radical. We have to do what's called rationalizing. So to get rid of that divided by the square root of 10, we're going to multiply by the square root of 10 on the top and on the bottom. So this is going to give us 1 times the square root of 10 is just the square root of 10. Actually, I want to make this in blue-black color. So this will be the square root of 10. Over square root of 10 times square root of 10 is square root of 100, which is just 10. Cosine of theta is our x over our r. So our x is negative 6 over our r, which is square root of 10, 2 square roots of 10, excuse me. Now I can reduce this 2 and 6 to get a 3 on top, so I have negative 3 on top. And then again, I have this radical 10 on the denominator. So I'm going to multiply by the square root of 10 on the top and the bottom to cancel out. So I'm going to have on the top, I have negative 3. So negative 3 times the square root of 10 is just going to be negative 3 square roots of 10. And on the bottom, square root of 10 times square root of 10 is the square root of 100, which is just 10. Basically, your square roots are going to cancel out. Tangent of theta is our y over our x. So y over x. So this is negative, this is just 2 over negative 6, which will reduce to negative 1/3. So cosecant of theta. So remember that I said it's just the reciprocal of sine. I'm not going to reciprocal this final result, because what's going to happen is I'm going to end up with a radical on the bottom. I'm going to reciprocal my simplified version over here, or my original, which would just give me the square root of 10 over 1. You can just write the square root of 10 if you wanted. Secant of theta is the reciprocal of cosine. You can use the formulas. I'm not going to reciprocal this one because then I'm going to end up with the square root on the bottom. I'm going to reciprocal this one, which will leave me with the square root of 10 over negative 3. And the cotangent of is the reciprocal of tangent, so if I flip negative 1/3, I'm going to end up with negative 3. Now you can always, again, use these formulas up here, and those will work as well. All right, determine which function each one of these are positive in each quadrant. So I'm going to write my formulas from the other side on the top real quick. I'm just going to pause the video and transfer those over, the sine, cosine, tangent formulas. All right, so here are my formulas from the front. And I did say previously that r is always positive because we're using the Pythagorean theorem to find r. So it's always going to be some type of positive number. So what I'm going to do is I'm going to label my quadrants. This is quadrant 1, quadrant 2, quadrant 3, in quadrant 4. So when I think about quadrant 1, any point in quadrant 1, no matter where I plot it, I have to plot a positive x and a positive y. And if r is always positive, that means everything in quadrant 1 is always positive. So all of them are positive. If I look at quadrant 2 here, I've got to plot a negative x and a positive y. Negative x and a positive y. So anything with an x really is going to be negative. So cosine, tangent, secant, and cotangent, all of these are going to be negative because I'll have a negative x. A negative divided by a positive divided by a negative, positive divided by a negative, negative divided by a positive. So the only ones that are going to be positive are the ones that don't include x. So my sine and my cosecant. So sine and its reciprocal. Now if I look in quadrant 3, anything plotted here, I'd have to have a negative x and a negative y. So both x and y are going to be negative. So here I'll have a negative divided by a positive, a negative divided by a positive. Tangent will be a negative divided by a negative, which will make it positive. So tangent here, it'll be positive. And then obviously its reciprocal will be positive as well, so cotangent. And in my last quadrant, I'd have to plot a positive and then a negative. So anything with y is going to end up being negative. So this is going to leave me with cosine and its reciprocal of secant are negative here. Now one way that I remember that these functions are or which one is positive, awesome for all, students for sine, take for tangent, and then calculus for cosine. So awesome students take calculus. Which one? It'll tell you which one are positive. All right. Example 5. In which quadrant is theta if both cosine and tangent have the same sign? So I'm going to look through. And I like to just kind of go through my quadrants and see which one. So in quadrant 1, cosine and tangent are both positive. So they have the same sign in quadrant 1. If I go to quadrant 2, sine is positive, which means cosine is negative and tangent is negative. So they both have the same signs in quadrant 2. When I go to quadrant 3, tangent is positive, but cosine is going to be negative. So it's not that one. And then in 4, cosine is positive, but tangent is going to be negative. So just 1 and 2 for A. B, where is cosine negative and sine positive? So cosine is going to be negative. These two, it's positive. So cosine is going to be negative in 2 and 3. So where is sine positive? So cosine is negative in 2 and 3. The only one where sine is positive is quadrant 2. So this one only has one answer. So where do cotangent and secant have the opposite signs? All right. So here, 1, they're both positive. 2, they would both be negative, because these are the only positive ones. 3, cotangent is positive, so that means secant must be negative, so this one, quadrant 3 works. And if I go to quadrant 4, secant is positive, and cotangent is not listed, so that means it's negative. So quadrants 1 and 4. Now, reference angles. These aren't on the homework assignment, but they're super important to know. Notice on example 2 and 3, this was my theta, my angle that I found. But when I looked at my triangle that I drew, I only drew this triangle, the angle for this part. And same thing here. Here was my triangle my angle that I measured. But this was the part that we used for sine and cosine. Reference angles is what lets us do that. They are the angle formed with the terminal side and the x-axis. The angle formed with the terminal side and the x-axis. And some important characteristics of these are always going to be positive. So reference angles are always positive. And they are always going to be between 0 degrees and 90 degrees. Or if we're talking about radians, 0 and pi over 2. Okay, so let's look at A. Sketch the angle and then find its reference angle. So first I'm going to sketch 210 degrees. So remember when I sketch it, this is 0 degrees. If I go straight up, it's going to be 90 degrees. This is going to be 180 degrees. 270. And that's 7. Looks like another 2. If I go all the way around, it'll be 360. All right, so there's one side. Now, 210 is between 180 and 270. So I'm going to draw my angle in quadrant 3. So here, this red here is my angle. It is 210 degrees. The reference angle is between the terminal side and the x-axis. So this part here, between the terminal side and the x-axis. So to find this, there's different ways that we can look at trying to find this. You're going to take whatever the bigger angle measure is, the bigger known, and then subtract the smaller known. And the smaller known is always going to be, one of them is always going to be one of your coordinate axes, so 0, 360, or 180. Okay, so here, the bigger one is 210. So I'm going to take 210 and subtract my smaller known. The top half will be 180. So 210 degrees minus 180 degrees is 30 degrees. And that is our reference angle. You can check it to make sure it's always positive and between 0 and 90 degrees. All right, B, negative 5 pi over 4. So let's sketch this out. If I don't go anywhere, this is 0. If I go all the way around, and remember we're talking about negative, it's a negative. So this means I'm going clockwise. So if I go all the way around is 2 pi. So this will be negative 2 pi. So if the whole thing is 2 pi, then that means half of it will just be pi. So this is going to be negative pi. Okay. Do that. So now if this is 1 pi, then this right here would be half a pi, or negative pi over 2. So if this is a half a pi, I have 1/2 plus 1/2 is 1, plus 1/2 is 1.5, so this will be negative 3 pi over 2. Again, this is like negative 1.5 pi. This is like 0.5 pi. So when I'm looking at negative 5 pi over 4, negative 5 pi over 4, 5 over 4 is 1.25. And 1.25 is going to be between 1 and 1.5. Our reference angle is between our terminal side and the x-axis, so it is this measure right here. So if the whole thing, this whole measure, the bigger one, is 5/4 pi, and this is 1 pi, if I subtract those, that means my reference angle has to be pi over 4. If you end up subtracting them backwards and you end up getting a negative, it's going to be the same thing, but remember it always has to be positive, always between 0 and 90, or 0 and pi over 2. So if you had gotten negative pi over 4, then you would have just made this positive. So what I'd like you to do is pause the video, try C and D. I wrote really big here, so I'm just going to go to the next slide and do C and D. I'm just going to have the answers in the workup. I'm not going to walk them through them. So go ahead and pause the video. All right, so here are the answers to C and D. Again, always make sure if you subtracted backwards, you would have gotten the negative version of these. So just make sure that you're subtracting properly, and it's between 0 and 90. All right, I'll be available and remind. We're on Zoom during office hours if you have any questions.